So, hi, myself Sikha Singh. I'm student in Newton School of Technology. I'm in the second year. So today I'm going to teach you a very important topic in a Python the programming language, that is linked list. So basically, when you will come after the listening what is array list, then the topic linked list will come. So basically we'll go through a PDF. So what is a linked list? Here written, a linked list is a linear data structure where elements known as nodes and stored as non-continuous manner in a memory. So linked list have two things, like head. Okay, so I will explain in simple one. A linked list is a linear data structure where element that's called node are stored in a memory. Okay, unlike array is stored. So you can see here this first element of the list is called the head, and last one after 5 it's null. So there are two type of list, linear versus non-linear. So basically you can see the diagram. This is linear data structure and this is non-linear data structure, like a tree structure. So what is the linked list? Each nodes contain the data and a reference or a link to the next node in the sequence. So basically it's saying that each node have its own value and the value of the next node and the data set. Like I will give you an example. If you are sitting in a classroom of 20 childrens, so 20 all of them will know each other, like I know the another will know the another, like this linked list follow. In my I have stored the data of one, the one have stored the data of two, like this it continue. So the first element is head, you can see having the data and the data of next node. The second one is having his data and the data of his next node. So each node contains the data and reference or link to the next node in the sequence. So you can see the data is 11 and the next 200 is the position where the next node is stored. So head and tail reference. The first element of the list is called the head and the last one is called the tail. Like so, static versus dynamic memory. So array needs a continuous block of memory, but in dynamic linked lists don't need to be continuous in memory, they can grow dynamically. Basically it's saying if an I having an array, so array is a continuous block like 1 2 3 4 5 6 store, but in a linked list there is no necessity ki one is stored after the 2 or 3. It is important the path is stored like after 1 it will be 2. So there are three type of linked list: singly linked list, doubly linked list, and circular linked list. Three types. What is the difference between singly, doubly, and circular list? So it's very simple. Like in singly linked list, head and tail, we are going to 5 to 10, 15, 20. In the example you can see. So we are always moving forward, not back, going backward in the direction. So this type of list is called singly linked list. But in doubly linked list, so they have both. 5 have the data, the position of 10, and the 10 data have position of both 5 and 15. Similarly 15 have the date, the position of 10 and 20. But in circular linked list is very simple. The tail is direct connected to the head, that is called circular linked list. The difference between single linked list, double linked list, and circular linked list is very as you can see. So we'll go through the next page. 1 minute. We have done this now. Advantage of linked list. So what are the advantages of a linked list, why we are studying? So here you can see the dynamic size, because linked list have dynamic size. Linked list can grow or shrink in the size of dynamically, allowing affecting memory is utilized without need of designing. So it's dynamic, it can be used, like it can grow, it's not a particular size. Easy to insertion and deletion. Inserting or deleting element in a linked list is more effective because it only involves the changing in the next pointer of a node, where array requires shifting the elements. So basically it's saying key in linked list we're having the linked list, so we can delete or insert it easily because the particular value have stored the position of the next node. That's why. So from this we can do, so no memory wastage. Array can leads us to waste memory space, allocates array size in the large than needed capacity. Linked list allocated memory as and we require. Saying key in array we can lead the waste memory in, if you're solving with a linked list we can minimize the time limit okay, and locate the size. So I will explain you a real world application, like having a browser history. Modern web browser used linked list to keep track visiting URL. This allows user to easily navigate forwards and backward. Like I have opened, if you have seen, I will show you a real example. See, first I will explain you this, then I will show you the example how actually the linked list is working. So guess I am on a tab, like I open the Chrome and I'm on the tab, this null tab. Okay, so actually then I open the YouTube. After that I open the Instagram, Facebook, Google. If I have seen a sign, like I will show you. You can see if I open Newton portal, the data is stored, the first one like this. After that I open this, I've been here, so the position is stored. You can see this page came again. So this structure is about doubly linked list. Okay, this is called. So YouTube means the main, when I opened the Newton portal, it was our first node, and the last node was that when the questions are there. So you can see have given one example to you. Now this is also a second example, real world application, music playlist. App like Spotify or Apple Music may use linked list in managing the playlist, where each song is a node with a link with the next song. Like you are playing one song, like think example, you have to listen a Haryanvi or Punjabi song. If you are played a Haryani song, is this Haryanvi song, the next song will be also in Haryanvi, because they all are connected to each other. Like I have my playlist, the song 1 data is stored, and after that the song 2 data is also stored. The position of song 2 data is stored in data song 1. So this is how linked list works. So it's a doubly linked list. So, another real world, as I explained you, image viewer application, like linked list can be used to apply image viewer with the next and the previous functionality. Each node represents an image and then navigate through an image. Like you have used earlier this kind of thing, like there are many multiple images in your laptop or a desktop. So you click this one to go right and this one go left. If you open a middle one, you an random image from the folder, and you will try to click this one, it will not take you to the first image, it will take you the next or the previous image, the image you have opened. This is about the linked list. This was the third example. So basic node structure in the linked list. So now I will tell you about the code, how to write the code, how to make a class. So basically in listing we make a class called nodes, where we define it by self and data, and self that next stores none value. So we will do basic operation on the linked list, inserting a new node and deleting a node. So first of all we'll go through inserting. Means we are inserting a new element in the middle, or at the starting, or the at the end of the linked list. Inserting in linked list: insert node at the beginning and insert node at the end. We will go through inserting at the beginning and at the end. So now we'll go through. So insert node at the end, what it means: we are like, this is our main node and this is our tail. So it's telling कि we have to add the new memory after the tail. So in this, what we will do, we will transfer the tail value to the new value at the last position, because of here 5 is the last one. Okay, so now we have to add the new element at the end. So we have to transfer the value tail to the value we are going to add. So here written also you can see the next pointer of the last node pointer is null. So we go. So you can see here, I will do it here. Okay, node next to not null jumps to next node. So 1, you can see 1 2 3 4 5. So we will go after 1 2, after 2 it's 3, after 3 it's 4 and 5. So after 1, the next node is 2. I will jump through 2 3 4 5. Okay, so what you have to do, in a simple word I will tell you, we have to go through if the next node is null. If the next node is null, then we have to add the value at that position. Like you can see after 1 2, it's not null, so we will not add here. We will again iterate. After 2 it's 3, again we will not add here. After 3 it's 4, it's not null, we will also not add here. After 4 it's 5, also we can't add here, because we need the value where the value of node after that is null. So after 5 it's null, so we got the position and we will add the value here. After 5 we will add. Okay, so one minute. So as I told you, node next to not null jump to next node. It's a clear visualization. You can see in the PDF key, the arrow is pointed at the 1. Now the node next to is not null to jump to the next node. Okay, then we came to 2 as I told you. So again the node jump to the next not null, then it jumps to 4, which is the next element is also not null, then 5. 1 minute guys. Okay, so after 5 node next to is null, but after 5 the value is null. So 5 is our last node in this case. Okay, so as I told you, we are adding the new node value after 5 6, because we are inserting at the end of the linked list. Set the next pointer of the last node with the new node. So time complexity is big of n of inserting. So 6 is our new node, 1 is our head node. Okay, now we have to insert. Simple. So set the next So now I think it's we have done the main inserting node at the end of the linked list. Now we will go through inserting the node at the beginning. So insert the node at the beginning. So we have a node 6 and our first node is 1, so we have to add the value 6 on the beginning of the linked list. So I will go through a visualization and the PDF itself only. So here written, set the next of the new node to the head node. What the task I have to do, set the next of the new node to the head node. Okay, so basically what we have to do, we have to make 6 a head node, and I have to make 1 as the neighbor, head's neighbor. Okay, so now head node is 6 and new node is 1. Updated the head node to the point to the new nodes. The time complexity is big of O of n. Deletion. Now we'll have learned how to insert at the beginning, how to insert at the end of the linked list. Both of them were very simple by the logic as you see. Okay, I have told you this by visualization of a diagram also, and I have told the logic behind it. Okay, so now we'll go through deletion, how to delete a node from end or from beginning. So again we will go through two same topics, deleting node at the beginning. In previous we have learned inserting node at the beginning and delete node at the end, and we have learned how to delete add a node at the end of the linked list. So now we go through delete the last node. It's saying I have to delete the last node. You can see I have 1 2 3 4 5, so I have to remove the 5 from the linked list. So basically what I have to do, I have to iterate until the second last node. See, I will explain you in a simple one, don't go through it. Key, I have to go till where the last node value, means the last how can I explain, iterate until the second last node, means I have to go through the second last node, because here you can see our last node is 5, so we will go till I have to iterate till 4. The second last node is where next dot next is null, means you can easily see if I am standing on a 4, the next, our next value is 5, and dot next means again it's saying the next value is null. After 5 it's null, you can see. So will tell you what I have to do. Simply it's saying we are standing on the last second position, like first person is standing at the last second position and one person standing here, so I have to iterate to the last second one. Then I have written here next dot next is null, means after 4 we will go to 5, and after 5 it's null, so we have to iterate here, we have to see this thing and this. Okay, so this is only the thing I can. So it's explaining you node next to node next is not null, means you can see at 1 next is 2 and next is 3, that is not null. So we will go to the next element 2. Again you can see the 2 have the next node as 3 and next is 4, so it's 4 not null. So we will jump through the next node again, like you can see if I'm standing on the position 2, the next element is 3 and the another next element is 4, so 4 is not null. So we'll, what I have to find, next dot next is null. Okay, so we will jump again to 3, So here you can see key 3, the next node is 4, and dot next is 5. It is also not none value. So it's, as I told you, we will again jump to the next node as usual. So here you can see the next node is 5, but next dot next is null. So we got the last second value in the linked list. So what we have to do, set the next pointer to the null. My task is to set the 4 as null, means when I reach the last second value, I have to set the next value after 4 is null. Okay, means in simple word I will say that I have to remove 5, and at the place of 5 I have to put null. Okay, as you can see in the diagram also. Okay, we have removed the 5 and added a null. Okay, delete last node. This is also in special case. In the linked list has only one node, or linked list has only one node. For this case we so this is in a special case, like uh, you can see a list, linked list is having only one node, number 1. So this is called the special case. For this case we will remove the current node and set the head as a null. So in this what I have to do, okay, if I'm standing on one and the next one is null, then the simple we will remove the one, and instead of one we will put null. So remember this, because a linked list having a single node, so we at this place of a single node we will add the value null. Okay, so moving to the next page. So we have seen the delete last node. Okay, so we'll see also the time complexity used in this. The time complexity is big of O(n). Okay, moving to the next one. So we have learned 3 things till now: inserting the node at the beginning, inserting the node at the end of the linked list, deletion of the node from for the last in the last of the linked list. Now we are going to learn deleting the first node in the linked list. Okay, so as you know, 1 is our head and 5 is our tail in the linked list, as you can see in the diagram usually. So we have to remove the first node, means we have to remove the head. Okay, so basically I will give you an example. If there are 2 person and 1 chair. Okay, so uh, basically what happened, only 1 person is allowed to sit on the chair, so we have to remove 1 and give the chair to the second one. Okay, so in this case is also simple. If 1 is a head, I will try to make 2 as a head. Okay, then only we can remove the 1, because the in the linked list starting value is our head and the end value is our tail. Okay, so basically we will go through an diagram uh, that will be easy to understand. Okay, so as I told you, to remove the head node, set the head pointer to the next node. As I said you that I have power to sit on a chair, I have also power to okay. So as you can see in the diagram, to remove the head node, set head node pointer to the next node. Okay, so head is pointed to the next node, that is 2. We never iterate backward. Okay, so in linked list, singly linked list, we never iterate backward, we always iterate on the front side only. So this is also having a special case in this key, that we in the special case when deleting node from the last was having 1. Okay, you have understand that in this also we have a special case, that the linked list has only 1 node. Same case was there also in deletion of the last node in the linked list. So for this case we will remove the current node and set the head value as none. Okay, for same concept was and the deletion node were from the last. Okay, so keep in this mind and we will move forward. Okay, so the time complexity of deletion of first node is of 1. Okay, so we've completed what is linked list, type of linked list. There are three type of linked list: circular linked list, doubly linked list, and singly linked list. Okay, and we have completed four things: inserting from the beginning, inserting from the end, deletion from the end and from the beginning with a visualization diagram. Okay, so we are moving through the next one. So this was now we'll go through the part 2. Okay, so part 2, linked list part 2. It's part 2, as you all know. So I will give you a quick recap what I have studied. Structure of linked list. There are three type of structure, as I told you: doubly circular linked list and singularly linked list. Okay, we have read four things: inserting node at the beginning, inserting node at the end, delete the first node and delete the last node in the linked list. Okay, so I think you have understood this completely in a very good manner. I hope so. So this is something new. We have to find the middle in the linked list, middle value of the linked list. Like I have 1 2 3 4 5 6 7. Okay, I have to find the middle one. What I will do, it's a simple that in there are total 7 numbers, so I will add 1 and divide by 2. I will find the middle element. Okay, so in this, at the same concept, the linked list also work in this form. So how I got to know the 3 is the middle one? I will tell you by visualization that 1 2 3 4 5 is there, 1 2 and 4 5. The 3 is the middle one. But what is the main concept behind finding the middle one? So as you can see, 1 is our head, 3 is our middle value, and 5 is our tail, and 5 the none. Middle of the linked list. So there are two examples: 1 2 3 4 5 and 1 2 3 4 5 6. We'll move to the next page. We will use brute force method for this. Okay, so as you can see in the diagram, there are linked list we have made 1 2 3 and 4, and 3 is on the red. Okay, so going with the transverse the list, we will iterate through the linked list to count the total number of nodes. As usual, as I gave you the example that I have a 7 number, this number are 1 2 3 4 5 6 7. So I will count the total number. Okay, to find the thing if it's even. Okay, so I will take the example. Let's take 6-digit number: 1 2 3 4 5 and 6. So I have to find the count of the total number. The count of total number will be 6. So I have to find the middle number. What I will do, total number divided by 6. So I have total 6 divided by 2 3. So 3 will be our middle number. Okay, so in this example, as you can see, 1 2 3 4 5, 3 is our middle number. So and first what we have to do, iterate through the linked list to count the total number of nodes. So we are talking about nodes, then this is the node. Okay, so we will count the total number of nodes present in the linked list, then we will compute finding the middle value of the element. So count, total count divided by 2, it's an integer division. Okay, then we will transverse again starting from the head and move to the mid step, we reach the middle node. So once we got the middle value, we will again start from the first node and we will iterate. From this process we will get the value of middle value in the linked list. Return the middle node. The node at the mid position is the middle node. Okay, so middle of the linked list. Can we find the middle in the single pace? Is it possible to find the middle node without computing the length? This is two questions which are asked. Can we find the middle in the single pace, or is it possible to find the middle node without computing the length? Means the second one is saying it is possible without counting the length of the linked list. Can we find the middle value? Let's see what's the answer. Okay, so 2 pointer. Okay, so for odd number like 1 2 3 4 5, 5 is an odd number. Okay, so we will go through an example. One second. Okay, we're going. So you can you can see there is 2 pointer, slow and fast, focusing on first node head. So what the slow one is doing and what the fast one is doing. One is moving one step forward and the fast one is moving 2 step ahead. Like there are two boys who are doing cycling. Okay, like you can see in the picture, the first one is moving one step, the second one is moving 2 step. So on this term we are doing, so we have an arrow, two arrow, slow and fast. The slow arrow is moving one step forward and the fast arrow is moving 2 step forward in this case. So as you can see in the diagram, as I told you, the slow one is the slow pointer reaches to 2 and the fast pointer reaches to the 3, because I told you the fast one is moving at a 2 step header. So stop when the fast point reaches the last node. So what you have to do actually, when the fast one reaches the last node, we have to stop at the time. Okay, so uh, it's a very thing. So as you can see from the starting, I will show you, we have 2 pointers, slow and fast. Now the slow one will move 1 step ahead and the fast one will move 2 step ahead, and at the time we have to stop when the fast node reaches to the last node of the linked list. As you can see in the diagram, you can visualize by seeing it easily. So, 1. Okay, so here also you can see the fast pointer have reached the last node. So instruction is also written here, stop when the fast pointer reach the last node. So let's see an example. Okay, you have listened the story of turtle and the rabbit. Rabbit was running very fast and the turtle was slow. So this was an example. You can see a rabbit is taking 2 step forward. Like at the starting point both were at the same position, but when the races start, rabbit was at the point 3 position, turtle was at the point 2. For it is for easy visualization that you can visualize. Okay, so for even number, for nodes, let's see now even number. So in this also we have two fast and slow pointers. So as going to see in the diagram, same structure will follow for this. Okay, but in this case when the count of nodes in a linked list are even and odd. The difference is only one thing. In the odd, when the past when the pass pointer reach the last node of the linked list, then we have to stop. But in the even number of nodes in the linked list, the fast nodes should be reached at the none position, then we have to stop. As you can see in the diagram, as usual, our slow one is moving one step ahead and the fast one is moving two step ahead. And for even condition, we have to stop only when the fast one reaches to the none. Okay, so you can visualize by seeing the diagram like moving. Okay, so the fast one reaches to the none and we stopped. Two pointer method, slow or fast. This method is called two pointer method. We make two things, slow and fast. So use two pointer method and initialize slow and fast pointer at the head as I explained you, and move the pointer. Slow moves one step at a time, fast move two step at a time. Stop when the fast reaches the end. If the fast or fast dot next become null or slow is at the middle, return the middle node. The slow pointer now points is the middle node. Okay, uh, one one I will show you for the odd one once again. As you can see in the diagram, for the odd condition, when the fast pointer have reached the last node, the slow node reaches the middle of the linked list. So this is the process. Okay, as I told, it's completed. Now we will see the code also. So we are defining find middle, head, slow equal to fast equal to head, because in the diagram you have seen that the point at the one we have pointed two arrows, slow and fast. So here you can see slow equal to fast equal to head. So we will reiterate a while loop, the fast and fast dot next. Okay, means ki till when we will reiterate that the fast dot next is not none. Okay, the slow equal to slow dot next, fast equal to fast dot next. It is a visualization of what you visualize we are writing in the code itself. Okay, followed circular delete. Okay, so we will go through one problem. Okay, given a singly linked list, check if the linked list has a loop, circle, or a loop means that the list node of the linked list is connected back to the node in the same list. Means I have previously explained you what is circular linked list. Circular linked list means if the last node is connected to any node of the linked list, then the term is called circular linked list. As you can see in the diagram itself, one is our head, 2 3 4 5 and 5 6 7, then 8 is again connected with the 3. Okay, again everyone will think how will we solve this problem. Okay, going to this problem again. Step 1, both pointers slow and fast will point the head node. As usual, as we have studied, keep both we have made a fast and slow no pointer which will points to the head one. Okay, step 2, slow will move one step ahead and fast moves two step ahead until slow is not equal to fast. So in second step, what will it's saying we have to move till the point where slow and fast both should be equal. Okay, so you can visualize the diagram also. The one, the slow pointer is on 2 and the fast pointer is on 3. Again, the slow pointer is on 3 and the fast pointer is on 5. So the slow pointer is now on 4 and the fast pointer is now on 7. Again, you can see now it's very okay, the slow pointer is on 5 and the fast pointer is on 3. And you can read also the slow will move one step ahead and fast will move two step ahead. Same line is written as I told you. So again we will same continue this process. Okay, now you can see the slow and the fast pointer are at the same position. The node 7, the value containing node containing the value 7, the both pointer are pointing to the same node. Okay, so we have find the middle value in this. Use two pointer. Okay, slow and fast pointer at head, move pointer, slow move one step, fast move like this. Checking up for circle, slow equal to fast. Stop condition is also there. Like now we will see the code. So as a simple, for circular we will put one condition. When f slow doubles equal to fast, then we will return true, because for circular linked list slow equal to fast should be necessary. Okay, so till now what we have learned, we have learned what is linked list, type of linked list. There are three type of linked list. I will once more tell you: circular linked list, singly linked list, and doubly linked list. We have read four operations: inserting at the end, inserting at the beginning of the linked list, deletion at the first position, deletion at the last position. Finding, we have done 6 things. Okay, and we have also done finding the middle node of the linked list for the even and for the odd. Both we have learned. Okay, both we have learned till now. And also we have learned how to find the middle element in the circular link list also. So I will one more tell you, in circular link list we have to always see that the slow pointer and the fast pointer should be equal. Okay. So this was all about the link list. Okay, our next topic will be graph after this. So we have learned what is linked list, how it's work, and where it's really comes to the learning environment where it is used. We have seen two example, as I saw you in a Chrome, that we open a tab, we go back to the same tab, we open, in the tab multiple tabs are there, we open and we go back. Okay, we have done this also. I have given you an example of a folder containing photos that you are clicking on the next and the next photo is opening. This was all about the example of a linked list. So if you like this video, uh, please comment on this as usual. So this is all about the linked list I taught you in this topic. I will share this PDF to you all. Thank you again. I will tell myself Shikhar Singh and I am the second year student in the Newton School of Technology. Thank you so much.